Continuing on with some more introduction to representing data, how it's stored. The TIN network is kind of an interesting concept. What it allows us to do is to take some data that perhaps looks like completely random points, and our eye is confused as to what's really happening here. So we can take these points and connect these points with lines. So each point connects to lines to points in proximity with lines, and then further we can investigate characteristics of the line, and from these three lines characteristics of this particular facet. So we can take this information, which is individual points, construct line data from those points, and then facet data from the surfaces that are created in those what's called an irregular triangular network. So what are they? They are points, edges, and facets, and so you can kind of get a feel for what that would look like on a larger scale. And so we could have, if these were elevation points, for example, the slope of the line between the nodes. So here's the node. So this slope would tell you along this line, if you were going to walk from this point to this point, would you be going uphill or downhill, and so on. And so if we have a slope for this line, a slope for this line, and a slope for that line, that will allow us to tell us the orientation of the slope of the of this facet. So with that, and once we know the slope and how it's angled, if we attach some lighting sources, we could say, well, this one, because it's facing away from the sun, will be in the shade, or if it's facing directly at the sun, it will have a brighter surface. So we can assign the brightness of this surface based on which way it's facing with respect to the light. Now, I do want to point out that this is not something that we're going to do in class. This is something that we can just apply these algorithms that have been generated to see how they look and to see what works for us. So representing a layer here, this is a digital elevation map. So in this particular map, what we have is that each of these individual pixels is color coded, so that as the color changes from dark, which would be low, like in the valley, and then you're going up the hill here to a higher value up on top. So we can get a fairly good idea that this is maybe a little stream that runs up through here, and if we want to go for a walk, we might want to walk up this stream, and we have a choice here and get to the top of the hill over here. This can be taken and converted into vectors. So if we take this information and come into vectors, where the vectors would be lines, and the lines would be all lines of a common height. Well, here it's a little difficult to understand because we don't know if this line is a low line and this is higher. So are we going up the valley here? We would have to know what the value of these particular lines are, what the numeric value of elevation of those lines are. With a TIN network, we can take the same data and we can apply it in this sort of a fashion, and you can kind of get a feel here. Now this is not actually this thing represented, but you can see then that this looks like a ridge line. And so this would be, the sun would be hitting on this side and would be shade on this side, and then correspondingly the sun here and shade on the other. So you start to get a feel of the topographical view by how this data has been represented. And again, what this would be is we have a raster image of individual elevations, and we're connecting a network and constructing this from it. Okay, so back to what we've talked about earlier. We've got the real world, a data model, and a data structure. We've saved this data, and again here we're not going to be doing this in class. This is kind of a review, but how are we actually saving this data in file and file structures? In sort of historical GIS, this was very important information that because as you were building these databases and files, now the software all really kind of handles it for us. What is somewhat important is that we do understand the characteristic of what we're getting. In other words, is it an 8-bit value, a 32-bit value, and so on and so forth. So we have to be careful because if we mix types and so on, we can get some problems. Probably the largest issue that you'll find is that a good portion of the data that you come up with will be in metric units, and other data you may have would be in English units. And so if you try to combine those two together, things just don't look right. And so the cross between unit conversions is probably the larger area that you're going to get involved in. Metadata, each file that has been put out someplace by some organization for us to use has what's called a metadata. And so you have the data itself, and then you have another file or a header to the file that tells you information about it. So for example, here, this would be telling us that for each pixel, there are 32 bits of information. The metadata is something that's standardized now, and if you're going to be a producer of geographical information that you're going to post, you'll need to include metadata for it. Okay, so the metadata is the header. It talks about who created the data, how it's stored, and what sort of representation it's stored as. And then we have the spatial data. And spatial data is what shows up on the map. And then we have a third characteristic, which is the attribute table. So anything that shows on the map will have a characteristic in the attribute table that tells us what the values are for that particular point. This would be, so for example, we looked at one that was fire hydrants. So the metadata may say that this was maintained by the fire department in the city of Rochester, for example. And then the spatial data would end up being points on the map within the Rochester city. And then the attribute table would be those characteristics that say that that particular point has so many flanges, so much pressure, flow rates, and so on. Old school hardware, we used to have a light table and a puck, and a little puck would go around for clicking on. So we'd have paper maps, and they would be backlit, and so you'd come along and click on the map and take that would create from the digital or the non-digital data to the digital data. Now we do things with just creating PDFs, and we bring the data in electronically. So scanning and bringing in electronically is much more common. Digitizing tablets are really kind of a thing of the past. Also getting data in, we have receivers, GPS receivers, so you can go around and make a click and it identifies where you are, for example, and then that can be downloaded into the software and applied to the map. Much of this is happening real time. Much of it is happening without our knowledge. Our cell phones are GPS hardware or GIS hardware. So it's really getting very, very inexpensive and transparent. So what are we doing? We have inputs, we have to digitize, we have to edit, we have to remove errors, we have to make decisions, we have to reduce it. There's a very large job in just getting data in. Second layer is to analyze that, to make decisions and determine what kind of information is there that's interesting that we may want to communicate. And then lastly, we are going to communicate that information to create maps that have good composition, that have a nice color palette, that have symbols that identify what's going on, many overlays. Displaying queries are basically a way that we can only display certain portions of the information.